So here we are with lecture number 10 of the University of Roehampton first year undergraduate creativity and computing course. The theme for this lecture is about software development, just looking at really four of the development strategies which are used, and I think there are interesting parallels between how software developers work and how teachers work, and that's one of the themes that I'm wanting to explore in what follows. You've already got some experience of developing software from creating your Scratch game, and this is really a chance to step back from that and think about what's happened over the course of the term and how you've coped with that particular project work and the challenges that are involved in Scratch development. And when we're together on Friday, there'll be a chance to chat about that, and I think that's really where we'll start on Friday, by having an opportunity to talk about our experience of learning to program in Scratch and to get something done in Scratch. And I'd very much like you to prepare a few thoughts in advance of thinking about what have been the critical incidents, what have you made of that particular process. Has this been, as I've suggested, it might be one of the hardest things that you have to do in the whole program is learn how to do this programming in Scratch. And what do you think about its place in the curriculum? There'll be more chance to think about that after you've been in school next term on placement. We talked last week about game-based learning, and I made the point that there were common features between what many of the advocates of game-based learning say about what computer games bring to the classroom and what the experiences of computer programmers, so that when you are programming a computer, you're very much focused on a set of goals. You're working towards a particular target. There is a particular outcome in mind there. Sorry, I'm turning off the speaker on my phone. You also have that strong sense of interactivity when you're gaming and when you're programming. When you do something on the computer, when you program a computer, it responds according to the instructions that you've given it. There's a tight feedback loop. You can tell whether your program is working. You can tell whether it's going to run, whether it's going to compile, whether it's going to work as you expect it to. Just as in a game, you know how well the game's going. The sense of progression is possibly harder to define in terms of computer programming, but we start gently with something like Scratch, and as you get to grips with that, you become more and more ambitious as to what you want to do. And in a few slides' time, we'll talk about that iterative development process if we take a bit of code that we've got and see how we can improve on that. There is, of course, as you will have experienced this I'm sure by now, that sense of having to overcome problems, having to overcome challenges as you're developing your software in Scratch. And perhaps for one or two of you, for some of the time, there has been that chimney high sense of flow where you're so absorbed in what you're doing as you're coding in Scratch, just as gamers talk about that sense of flow as they're so absorbed in the game program which they're playing. Nevertheless, in both domains, one might ask the question about where is the learning. Jonathan has this very helpful taxonomy which he describes as meaningful learning, and says for learning to be meaningful, one's looking for these 5 characteristics to be present, for it to be something where the learner is active, where the learner is constructive in the sense of making something as well as in the sense of making meaning, where there's a degree of intentionality there, where there's a degree of authenticity present, and ideally where there's a degree of being cooperational with other learners. And I'd hope that most of these boxes are ticked for your experience of programming in Scratch, and indeed for many of the ways in which we might use Scratch in a primary school classroom. Firstly, the notion of being active here, I hope, is very, very imminent, and that you are actually doing something. You're not simply listening to a lecture on YouTube. But no, you're programming in Scratch. You're doing something on a computer. You're constructive in the trivial sense of making something. You're creating your own program. But you're also, I hope, creating that understanding of how Scratch and ideally how a computer works, how software works, that you now have, I hope, a far clearer mental model of what's going on inside a bit of software than when you started the course. We'll talk about this on Friday. That I hope you've had a degree of intentionality here, that you've been able to do what you want with your game. And of course that's where many of the problems arise when you're doing this sort of thing in school, that children tend to be overly ambitious with what they want, and the need to scale back those ambitions once in a while may be important. Authenticity is hard to pin down, but do you think that the games that you've been creating are ones which children would want to play, which would keep children coming back for more? Or have they merely been an exercise in ticking a number of assessment boxes? I hope more of the former than the latter. And of course you've been working with a partner. There's that sense of pair programming, which is the reading I asked you to prepare to do in advance of this lecture. You know, everything I know about pair programming I learned in kindergarten. That this is an extreme programming methodology of two programs working together on the computer. And you read the results. I hope that is actually a really effective development approach. And that degree of working with a friend hopefully has been a positive experience thus far on this module. Okay, looking now at a few software development methodologies. Those of you who studied this at A-level will, I suspect, be familiar with the Waterfall approach to this sort of thing. That somebody reasonably well paid and working at the client's, or who runs the client firm, comes up with a list of requirements of what they need the software to do. Then possibly somewhere in the development firm, somebody who's a systems analyst or an architect designs the specification for that. So yes, the client comes up with a list of requirements, often in consultation with the developer. The developer then comes up with a design for the software. That then at a somewhat lower level is implemented by a team of programmers who tend not to be quite paid nearly as much as those who get to call themselves analysts or architects. There then is a crucial step in this process, and this was probably the one which you hated and would have enjoyed least when it came to the A-level exercises, that of testing that the software works. But that is absolutely essential to this and indeed to other methodologies. And then there's obviously work still to do in terms of maintaining the software, correcting any problems which weren't envisaged, and making sure that things tick over. So this is the classic model of how software gets developed. This is the sort of thing which obviously is renowned for its success in huge ICT projects such as the NHS database. Moving on, I think there is an analogy here though between how big project software development according to Waterfall works and how some curriculum development works. A Secretary of State might come up with a list of things which a curriculum has to do. Provide children with a sound foundation of core knowledge, for instance. And then teams of men, typically men, often wearing suits, meet in hotel basements or elsewhere to come to design that curriculum. So they come up with the documents, and those of you who have caught up with the news from the Telegraph will see some of the problems with that particular approach to curriculum design. Then a group of people who tend to get paid somewhat less, charged with implementing that curriculum. We call those in our line of work teachers. So here's a curriculum, then it's down to teachers and to schools to put that into practice. We spend quite a lot of time verifying that that works. We obviously see that in terms of assessment in our line of business, and sometimes when it's not working, new strategies such as the literacy strategy, the numeracy strategy, and other things get put in place as to bring things back on track. There are, as you could probably detect, this isn't always an entirely successful approach to either software development or necessarily curriculum implementation. And the Secretary of State, bless him, talks about giving schools much more freedom under the new version of the curriculum. And of course those schools which have become academies, the new free schools and indeed independent schools, generally don't have to implement the curriculum which others have designed. They're allowed to bypass this whole waterfall process. And at the moment, as you know, the ICT programme study is disapplied. So yes, we've had a set of requirements, but we've given up with that process. Sorry, that's moved back one slide. Okay, what are the other approaches here? I think these days a lot more software gets developed using this sort of iterative cycle to software development. This is the iterative approach, and this is very much what I wanted you to experience when it came to your Scratch game, that we have tweaked things as we've gone on. Yes, I did want you to come up with a list of requirements and to storyboard your game, but it's not once through this particular waterfall here. There are 10 marks set aside for the iterative development of your game, because I think this is a much more helpful model for software development. So yes, we start at the planning, or we can start with the planning. We come up with a list of requirements, we analyse and design those, we implement those, we test that they work. We then go back round the loop as you evaluate whether that's actually doing what you want it to do, and then you do some more planning and come up with a list of requirements of things which you need to change and analyse how that's going to happen. And if you look at how most of the software products that you are using day in, day out work, then this sort of iterative approach is much more characteristic than the waterfall method that you might have been told about back in A-level days. Think of your iPhone operating system, think of dear old Windows, think of Microsoft Office. It is not just create a bit of software and then keep it maintained. It's keep running around that loop, seeing how we can improve on what we've got. People will criticise Google and a number of open source projects for going around that loop really rather more quickly than organisations such as Microsoft or indeed even Apple might do. This, I hope, rings a few bells from the diagram you will have seen in a number of your core teaching and learning textbooks about the planning, teaching and assessment cycle, that you plan your lessons, you teach your lessons, you assess how the children have learnt, and then you evaluate whether your lesson was effective, and then hopefully improve on that for the next time you go around that loop and teach it better in your next placement or the next time you get to teach that project, which is why I think the evaluation phase matters so much when it comes to your experience out there on school placement as you're teaching lessons. Don't just do it once and start with the curriculum, teach your lesson, check whether it worked. Go round that loop of making sure that the next time you teach that it's a better lesson. It also, I hope, reminds you of the diagram you will have seen in Mitch Resnick's presentations about Scratch, of the kindergarten learning cycle, that we have that notion of imagining what we want it to do and then creating something, playing with that, the testing it, the checking that it works, sharing it with an audience, seeing what they think to it, reflecting on that process and then going round the loop again. I think Mitch Resnick makes it very clear that it gets better and better as you go through this spiral rather than just going round and round in circles, that this is always improving. And that's how Scratch is built, but that I'm sure applies to so many occasions when children are making things in school. You want them to always be getting better and better at what they're making. Okay, so that's the iterative development cycle, and that I think lies at the heart of the process which we've followed when it's in the development of our Scratch games. There are other ways of doing this, though, and the software industry has moved, or much of the software industry, the sort of cool, exciting, innovative bits of the software industry have moved beyond that sort of set-in-stone model to look at more agile approaches to this. So the agile software development movement, I suppose, the Agile Manifesto, says that these things are good. Following a plan matters. Agreeing the contract matters. Documenting what you're doing is important. Identifying the processes and tools that you're going to use. But actually the things over on this side of the scale are better still. So being responsive to change, collaborating with your customers in an ongoing process rather than just agreeing beforehand what you were going to do. And actually, comprehensive documentation, yes, that's fine, but getting software that works is really what you want, and software that works as soon as possible, so the clients have something to look at, so the clients have something to say, this is something which needs to change. It tightens up that iterative development cycle on a very, very tight time scale. And yeah, fine, focus on process and tools, but think more about the individuals and the interactions. And some of the work I'm doing at the moment is around taking this and applying this as an analogy, a framework to think about teaching. That, okay, a lot of our model of teaching is somewhere over on the right-hand side, that we plan our lessons, that we come up with a learning compact. This is something which we obviously have as a university, that we as academics do something and you as students do other things too, that everything should be documented, that we should have effective processes and effective tools to teach these things. But actually, over on the left-hand side of the diagram is where many of our hearts lie. That it's not so, follow the plan by all means, but actually as you become a better and better teacher, you need to respond to the change in the room and be willing to move away from your lesson plan when you know that it's not working. And rather than the formal notion of a learning compact, then actually the collaboration, not so much with our customers, although I'm conscious that you are all paying large amounts of money in fees, but collaborating with our co-learners, with our students, with our pupils, is much more interesting than that sort of formalised agreement. And okay, we don't think in terms of working software, but getting working knowledge, getting a set of skills which can be applied really quickly, rather than waiting for the end of the course. The tightening up that development cycle, and yes, focusing much more on the individuals in the room with us and our interactions with them, rather than the sort of more formal processes and tools. I hope an appealing prospect. So moving over to a more agile collection of pedagogies as we learn that lesson from the software development world. What do you think? Helpful idea? I'd be interested in your feedback on that. So moving beyond the Agile Manifesto, you have this sort of thing, which is that 12, is that 14 principles of Agile software development. So at this point, I'd suggest you pause the tape and have a look through those and think about how they work in our line of work. Yes, think about these in terms of software development. Think about these applied to your little Scratch projects. But also, I would encourage you to think to make that link and to think about how these ideas apply to the business that we're engaged in of teaching. Yeah. So working software is the primary measure of progress. We'd say working knowledge or a working collection of skills is the primary measure of progress, that your pupils, that your students can get things done. Simplicity, the art of maximising the amount of work not done, is essential. How much of the time in school is spent doing school rather than learning things? That actually, the reason why we emphasise this learning objective thing on your lesson planning forms is because that is the thing that matters. The activity that you plan is entirely subservient to the learning outcome that you want the children to achieve. And look at this, build projects around motivated individuals. Isn't that what we should be looking for in the classroom? Anyhow, if you want to pick one of those and throw that out as a question into the comment space on Blogfolio, then I think we could have some interesting discussions about how that applies to our line of work. As I say, pause the tape and give that some thought. I showed you this when we were talking about problem-solving strategies. Again, the pragmatic approach is very much an agile development methodology, and so there are links between these two aspects. And as the point I made, hopefully, back in lecture number 8 was about making the connections between how we would approach a programming problem, such as Scratch, and how we might approach a problem in the classroom. And, why is this a problem? That sort of critical reflection is something I think we're wanting to encourage very much throughout the whole programme. Other questions, perhaps we're not so good at encouraging you to ask. Is there an easier way to teach something, to do something? Schools are often relatively conservative institutions that don't always look for the easier ways to do things. Many schools tend to be slaves to history and will be relatively risk averse. This is something which came up last week in your questions about game-based learning as to why that doesn't happen more than it should. Moving beyond the agile approach, which says all of these things are jolly good ideas, you now have this notion of software craftsmanship. And again, there's a sort of manifesto of software craftsmanship, that the things on the right are good as far as they go, but actually there are even better things to be aiming for. That fine, getting something that works is fine, but actually you want that well-crafted software in which you can be proud of the craftsmanship that's gone into that. And some of the projects we've had submitted in previous years for the Scratch actually are ticking these boxes about it being something which has been lovingly put together rather than it merely works and does the job. And I would really encourage you to aim for that sort of craftsmanship type approach to the software that you're coding up in your Scratch projects. And again, one of my interests at the moment is taking this model and applying this outside of the world of software development to the world of learning, to the world of teaching. So yes, be responsive to the change in your classroom, but still focus on actually adding value there and making a difference to the learners, fine, be willing to go off at a tangent if an interesting conversation comes up during the lesson. But at the back of your mind, you've got to focus on the fact that you are there to teach and to add value, as they term it in software craftsmanship, or to improve children's learning outcomes. And yes, collaborate with your learners, but also think in terms of the partnership with your pupils being a productive one, that things are getting done there, and also look beyond just the learners in your class. We'll come back to this in a moment. So yeah, the working lesson is fine, but the well-crafted lesson is something even better to aim for. And I hope before long you have that experience of teaching a lesson which, yes, there is room for improvement, but that was a pretty good, well-crafted lesson, a lesson to be proud of, one which you'll keep in your folders, and as Nick would suggest, laminate that particular lesson plan. Not all of them, please. Okay, and yeah, focus on the individuals and interactions in your classroom, but do be aware of the community of professionals that you are joining, that you are part of, and that's not just your school staff, that's now a national and indeed international community of teachers that you have a duty towards, I would suggest, and a duty to learn from. Hoover and Oshinai, who write very eloquently about the process of becoming a software craftsman, make a number of points about software being a craft rather than an art, that craftsmanship is built upon strong relationships, both with your customers, i.e. pupils, learners, and also with a wider professional community. Delivering value to your customers over advancing your own self-interest, that your customers' needs, in other words, in our case, your pupils' needs, come first. And it's not a place for artistic expression. It is a place for building something that serves the needs of others, and that's something to be proud of, that you're doing something which is good for other people. And again, think about your Scratch projects in these terms. You have there a hypothetical learner. Is what you've done something which you just think is an interesting exercise, or is it actually something which is well crafted and which a learner would really get something from, that they'd learn through playing the games that you're making? The things that we build for our customers, our clients, our learners can be beautiful, but they have to be useful. And they say that part of the process of maturing as a software craftsman, and I would say as a teacher, is that ability to favour utility when that becomes necessary, that that is more important than the beautiful, is having something which is useful. It's a lovely quote from there is a lovely quote about have nothing in your house that you don't know to be useful or believe to be beautiful. And it will come back to me who that's a quote from before very much longer. Okay, so in terms of software craftsmanship, Hoover and Oshinai and Apprenticeship Patterns make a number of significant points and helpful points there. And again, this is an opportunity for you to pause the tape, have a read through the slide, and think about what that means in terms of developing software, but also again cross that bridge and think about what that means in terms of your process, the process that you're going through and becoming a teacher, a learning craftsman rather than a software craftsman, perhaps craftsperson. Commitment to inclusiveness is part and parcel of this. Taking control of and responsibilities for our destinies, a willingness to experiment, absolutely crucial to the process of becoming a software craftsman, and I would argue a learning craftsman. They have particular tips for those right at the very start of this process, in the first week in the job in the software development industry, and I think a number of these hopefully will make sense to you when you get into school next term on placement. Don't be ashamed of being enthusiastic about what you do. You bring that enthusiasm absolutely into the classroom with you. Concentrate on developing concrete skills. Be willing to say that you don't know things, both to your colleagues in school and to the children if necessary. Be willing to confront the areas which you don't yet know about. Keep motivated, and that motivation has to be something which you can sustain over the long term. Okay, it's a relatively short placement, but you need to be able to sustain your motivation and the enthusiasm over the whole of that. And I think we very much encourage you to draw your own map, to identify your own targets for improvement, but do stay in control of that process, and don't, in our particular context, or the training model at Roehampton, you don't have much choice but to stay in the trenches. Don't try to run before you can walk. You might find people who can act as mentors to you in this process of becoming a teacher, possibly in your placement school, possibly beyond your placement school. Cherish those individuals. They can be hugely important at all phases of your career. And Huvenosh and I, again, talk beautifully about this notion of sweeping the floor, the sort of notion of the Zen monk who spends 10 years just sweeping the floor of the monastery, and through that learns to become an expert. And there is no task which is too humble to undertake. And please do share what you learn. Keep in touch with one another. If you're using Facebook, use that. If you want to use Blogfolio for this, it would be lovely to hear how things are going on placement. And yeah, Apprenticeship Patterns, there's a free copy of this online, so I really very much recommend this book as an interesting place to think about this process of learning a craft, in your case teaching, in their case software craftsmanship. So they have how these patterns are linked together. So unleash your enthusiasm, confront your ignorance, and a few others on there which is well worth looking into. Find your kindred spirits, nurture your own particular passion. Not every aspect of the job is something which you will thoroughly enjoy, but focus, think about the things in teaching that you really do enjoy, and focus as much as you can on those. Good advice for software craftsmen. And this is called a pattern language, and pattern languages are really interesting in a whole range of design disciplines. They owe their origin to Christopher Alexander's book back in the 1950s. We've got a copy in the library if you're interested, which talks about the process of building a town, process of building a house, and says that there are common problems which the craftsmen working in these domains, call them civil engineers, call them architects, call them whatever, encounter time and time again. And having a way of talking about those problems and sharing common solutions to those common problems seems such a sensible thing to do. So Alexander's book, Pattern Language, starts to attempt to codify that. The object-oriented programming crowd took up this idea and applied it in their domain, and we have the book by the Gang of Four called Design Patterns, which applies a similar approach to the common problems which people encounter when developing object-oriented software. And more recently, folks like Diana Lorillard have taken up this idea and tried to apply this to our line of work, that the pattern languages also apply in the Craftsman and apply in the school classroom and indeed in higher education, that there are common problems that teachers have to solve, and coming up with a language to talk about those problems, this pattern language, and a language in which to describe the common solutions to those problems, is something which Lorillard argues very eloquently for. It's certainly an idea which appeals to me. She also makes points here about teaching is a craft, which is something I think the Secretary of State would very much concur with. In teaching, there is a formally defined goal. The imperative for teaching is that learners develop their personal knowledge and capabilities. It's hard to argue against that. It's closer to a science than an art, but it's a science like engineering or computer science, interestingly, or architecture, where the imperative is to make the world a better place. And she describes that as a design science. We might use the term craft for that. Lovely book by Richard Sennett called The Craftsman, which is well worth putting on your Christmas list if it's not too late to do so. Some nice quotes from there. Labourer with a sense of craft, engaged in work, in and for its satisfaction of working are their own reward. And the worker can control his or her own actions of work. Skill develops within the process. The labourer with a sense of craft becomes engaged in the work in and for itself. The satisfactions of working are their own reward. The worker can control his or her own actions at work. Skill develops within the work process. Work is connected to the freedom to experiment. Sorry, there's a number of sentences joined together without proper punctuation in there, but I hope you get the idea. And this lovely quote, which I think applies to our experience of problem solving and applies in the certainly in the process of getting our programs working, but also I think in other domains too. It's by fixing things that we often get to understand how they work and paying attention to the detail and getting things right. Okay, I think that's pretty much what I needed to cover in terms of the flipped version of this lecture. There's plenty of that there for you to put some questions about, for us to chat about when we meet on Friday. I want to sort of set the agenda for the next or the next week too. So as follow-up for this, if you could, either now or following the lecture, if you could identify the sort of critical incidents and reflect on the whole term's work as you've been working on your Scratch projects, I think that would be interesting to step back at this point and look at the progress you've made. Next week's lecture would have been quite different in that there is a video to watch rather than coming together in the room, because I want to set this time aside for tutorials. So we're going to be looking at open source software, or rather you're going to be looking at open source software, and I need you to have read that's 19 pages from this rather good book on the potential of open source approaches for education. Because next week is going to be set aside for tutorials on the Friday morning. So I'd like to see each pair for about half an hour, and we'll go through stuff in the progress that you've made on your game in detail then. So there will be a video lecture, and you can have a look at the slides in advance. I wrote a thing which upset a lot of people called an open source manifesto, and it would be useful for you to read that either before or after the lecture. Do play around with open source software download as much as you want to and get that installed on your machine and have a look at what's good around there. And then we're going to need a development snapshot of your game, all of the game files that you've got. Pop those onto Moodle alongside your plan and storyboard if you need to make any changes to that, and we'll have a look at that over the Christmas break. And then a couple of more extended readings over the Christmas break. If you've not read Livingston and Hope already, then please do so. There's also the report Shutdown or Restart from the Royal Society, which came out last January. So one or other of those I think would be a useful reading over the Christmas break. And then some things to think about on placement. I'd like you to keep your blogs up and running, so talk about significant examples of ICT, either as a subject in its own right, or of how pupils are using it for their learning, or how you're using it in your teaching. Do blog about any examples of pupils using computers as tools to support or enhance creative work, where they're making something, because that's been the theme, I hope, running through the whole of this term's course, and is something which we return to next term when we focus much more on creative tools. If you've got the opportunity to use Scratch or programmable toys with your pupils, that would be great. And you don't have to do that in lesson time. Whilst we say stay in the trenches, as one of those apprenticeship patterns, what is it, sweep the floor and stay in the trenches, then, unleash your enthusiasm as well. And if you can set up a lunchtime or after-school programming club, then why not bring your Scratch skills into the classroom with you? And it would be nice if you could share your Scratch games with the pupils that you're teaching on placement and get some feedback from them. Because remember, as I say, there's 10 of the points are set aside for that iterative development process.